Hello everyone, in today's video we are going to talk about variation functions. The objective of the lesson is to solve problems involving inverse, joint, and combined variation. So let us have the vocabulary words: direct variation, constant of variation, joint variation, inverse variation, combined variation. So let us have a recall in what we have learned from direct variation. The perimeter P of our regular dodecagon varies directly as the side lengths S and P equals 18 inches. And when S equals 1.5 inches, let us find S when P equals 75 inches. The first thing we need to do here is to use method 1. So let us find K using P equals KS. In here, we are just going to substitute our P and S. Solving for S, we are going to divide both sides by 1.5. In doing this K equals 12. Since we already have our K, we are going to write the variation function. So we are going to have P equals 12S when we substitute K as 12. From the original equation, P equals Ks. From here, we are going to substitute P, which is equal to 75, then dividing both sides by 12, S equals 6.25. That is method number 1. Now let's use method number 2, using proportion. So using proportion, we are going to have P1 over S1 equals P2 over S2. Substituting all the values that we have, 18 over 1.5 equals 75 over S. Then we are going to have the cross multiplication and then dividing both sides by 18. So 112.5 divided by 18, S equals 6.25. Whether method 1 or method 2, we derive at the same answer. Now let's move on to joint variation. A joint variation is a relationship among three variables that can be written in the form of Kx set, where K is the constant of variation. For the equation y equals Kx set, y varies jointly as x and set. The phrases y varies directly as x and y is directly proportional to x have the same meaning. So let us have this example. In this example, we are going to find B when volume equals 24 pi feet to the third and height equals 9 feet. So the first step is to find K. Using the formula V equals KBH, we are going to substitute all the values and then we are going to divide both sides by 36 pi, which is equal to K is equal to 1/3. From here, we are going to substitute our K in the original equation, V equals KBH. So we are going to have V equals 1/3 BH. And from here, substituting all the values, we are going to simplify the left side of the equation. It will become 3B. And then dividing both sides by 3. So we are going to have 8 pi. So therefore, the base is 8 pi feet to the second power. So let us have another example. We are going to find r to the nearest tenth when L equals 8 pi square meters and L equals 5 meters. In here, the first step is to find K using the formula L equals KRL. Then we are going to substitute the values. And then 18 times 3.5 is equal to 63. So therefore, dividing both sides by 63, K is equal to pi. Step 2, we are going to substitute it from the original equation. So we are going to have L equals pi RL. Then we are going to substitute all the values. And then from here, we are going to divide both sides by 5 pi. So we will be getting R equals 1.6. A third type of variation describes a situation in which one quantity increases and the other decreases. For example, the table shows that the time needed to drive 600 miles decreases as speed increases. So this type of variation is an inverse variation. An inverse variation is a relationship between two variables x and y that can be written in the form y equals k over x, where k equals 0, and for the equation y equals k over x, y varies inversely as x. So given y varies inversely as x and y equals 4, when x equals 5, let us write and graph the inverse variation function. So the first thing we need to do here, we have y equals k over x. And then we are going to substitute cross multiplication k equals 20. And then write the variation formula y equals 20 over x. From here, we are going to graph. So make a table of values for both positive and negative values of x. So I know everyone can solve for y in terms of x. So plot the points and connect them with two smooth curves. Because division by 0 is undefined, the function is undefined when x equals 0. Now, we are going to write and graph inverse variation. So using this given, we are going to write and graph the inverse variation function. The first thing we need to do here is to solve for our k. And to solve for our k, we are going to substitute 4 for y and 10 for x. Using cross multiplication, k equals 40. And then substituting our k, so y equals 40 over x. So from our formula, we are going to graph and make a table of values. So from here, plot the points and connect them with two smooth curves. So given our x, you solve for y. So from here, we are going to have this graph. When we want to find specific values in an inverse variation problem, we can solve for k and then use substitution, or you can use the equation derived below. So y sub 1 equals k over x sub 1, where k equals y sub 1 x sub 1, whereas y sub 2 equals k over x sub 2, it is equal to k equals y sub 2 x sub 2. So therefore, y sub 1 x sub 2 equals y sub 2 x sub 2 using transitive property where k is equal to k, or the substitution property. So in here, we are going to find the average speed of a runner who completes the race in 3.5 hours. For the first method, we are going to find k. So to find k, t equals k over s. So substituting all the values, we are going to have k equals 26.1954. So from here, we are going to substitute the value for k. So we are going to have the equation t equals 26.1954 over s. So from here, we are going to substitute our t. So in here, we are going to cross multiply and solve for s. So S is approximately equal to 7.48. Now, using method 2, the ratio and proportion, so substituting all the values, and then we are going to divide both sides by 3.5. So S equals or approximately equal to 7.48. So the average speed of a runner who completes the race in 3.5 hours is approximately equal to 7.48 miles per hour. Now, let us have another one. We are going to compute for the working hours it takes for 15 volunteers to build a house. So in here, we use the method 1. So we are going to compute for K, then solve for T. So T equals K over V, substituting all the values, then cross multiply. K equals 1,250. And from here, we are going to have the equation T equals 1,250 over V. Then, we are going to substitute for the value of V, which is equal to 15. So 1,250 divided by 15, it is equal to approximately equal to 83 and 1/3. And then using method 2, using the ratio and proportion, so we are going to substitute all the values, and then we are going to multiply 62.5 times 20, which is equal to 1,250, then dividing both sides by 15. So T equals 83 and 1/3 hours. So in here, the number of working hours it would take for 15 volunteers to build a house is approximately 83 and 1/3 hours. Now, we can use algebra to rewrite variation functions in terms of K. So this is direct variation and inverse variation. Notice that in direct variation, the ratio of the two quantities is constant. In inverse variation, the product of the two quantities is constant. So let us identify whether a table is a direct or inverse variation. So in table A, it is inverse variation because the product is constant. And then in table B, it is a direct variation because the ratio is constant and each case y over x equals 6. So that is how we determine direct and inverse variation. Now, how about table C? Is it direct, inverse, or neither? Since x, y, and y over x are not constant at all, this is neither a direct variation nor an inverse variation. Now, let us determine whether each data set represents a direct variation, an inverse variation, or neither. What do you think? Correct. The first one is an inverse variation because the ratio is constant. How about the second one? Correct. It is a direct variation because the ratio is constant. So y over x equals 0.2. Now let's move on to combined variation. A combined variation is a relationship that contains both direct and inverse variation. Quantities that vary directly appear in the numerator and quantities that vary inversely appear in the denominator. So let us have this chemistry application. The change in temperature of an aluminum wire varies inversely as its mass m and directly as the amount of heat energy E transferred. The temperature of an aluminum wire with a mass of 0.0 kilograms rises 5 degrees Celsius when 450 joules of heat energy are transferred to it. How much heat in energy must be transferred to an aluminum wire with a mass of 0.2 kilograms raised to its temperature 20 degrees Celsius? So in solving for this one, we are going to have step 1. We are going to find K using combined variation. So change in T is equal to K E over M. And then we are going to substitute all the values. So K is equal to 1 over 900. And from here, using the variation function, we are going to have change in T equals E over 900 M. So from here, we are going to substitute change in T, which is 20, and then we are going to cross multiply. So the amount of heat energy that must be transferred is 3,600 joules. So let us have another one. The volume V of a gas varies inversely as the pressure P and directly as the temperature T. A certain gas has a volume of 10 liters, a temperature of 300 Kelvin, and a pressure of 1.5 atmospheres. If the gas is heated to 400 K or Kelvin and has a pressure of 180 m atmosphere, what is its volume? So step 1, we are going to find K using the formula V is equal to KT over P. And then we are going to substitute all the values. So after cross multiplication and dividing both sides by 300, K equals 0.05. And from here, we are going to use the variation function. So substituting the value of our K, so V equals 0.05 T over P. Then substitute the value for your T and P. So we are going to have 0.05 times 400 over 1. So V equals 20. So the new volume will be 20 liters. So that's it for now. Thank you for watching. See you again next time. Bye.